Welcome, everyone. We'll just give it a few seconds as attendees join. Okay. Hello, everyone. Thank you for joining us today for a discussion on the state of security for a decentralized world hosted by the EEA. Today's call is being recorded and will be available to all attendees soon after the presentation. The EEA enables organizations to adopt and use Ethereum technology in their daily business operations, and we welcome any and everyone to join and become a part of our global community. At this time, we are pleased to introduce our moderator, Oded Israeli.
Hi, thanks, Brittany. So thank all of you for joining this Enterprise Ethereum Alliance webinar on the state of security for a decentralized world. I'm Oded, I'm the CMO of Valid Network, a blockchain security and intelligence startup and an EEA member. And today I have the privilege of wearing the cheerful hat of the low-cost host for this important webinar on behalf of EEA. What brings us here essentially? So we all see the growing popularity of cryptocurrencies and the growing adoption of blockchain and Web3 projects. And those are pushing technology one step at a time to a decentralized world. And while blockchain networks seem to include built-in security, as you might have heard from Vitalik Buterin on Ashton Kutcher's tweet this morning, we still witness daily attacks, hacks, and fraudulent transactions on-chain and in crypto trade, and those are costing people and institutions billions of dollars each year. So luckily, we have some of the brightest minds in blockchain security here with us today, all coming from leading companies who are EEA members, and they're going to share with us various angles of blockchain security in a discussion about the state of security, the challenges in the ecosystem, and the road ahead. So I want to thank, first of all, EEA for organizing this webinar, which is free for everybody to attend and watch, in a true attempt to collaboratively improve the state of security on blockchain. And ask if each of you, the attendees here, to invite your friends right now, live, and those friends who care about blockchain security to our webinar here, and also to use the chat box or Q&A button down below to ask your questions to our distinguished panelists. And we also have a Slido board, thanks to Charles here, with the many questions that many of you have asked prior to the webinar. And we hope to get through many of them during this session. And if you'd like, we're posting the Slido link right now in the chat, so you can go in and vote to prioritize which questions we're going to answer. So thanks again for attending. And I would like to first present our 4 panelists that are here with us today. First, here is Christopher Cordy. Chris is a software engineer on the Splunk blockchain team. In his current role, he works on Splunk's Ethereum and Hyperledger Fabric integrations. Previously, he has done DLT cybersecurity research at Sandia National Laboratories, and his research interests include blockchain network security and layer 2 networks. Hi, Chris.
Hello.
Also here with us is Martin Derka. Martin is a senior research engineer at Quantstamp, Inc. Martin holds a PhD in computer science from the University of Waterloo. He also studied at Brock University, McMaster University, Masaryk University in the Czech Republic, and has additional degrees from some of these. Martin, you're a champ. You know, I don't understand how you got to this webinar through all of these universities. He's also the former Vanier Scholar and a brief NSERC postdoctoral fellow at Carleton University. Hi, Martin. Thanks for joining us.
Hello, everybody. Thanks for having me.
You're welcome. Also with us is Dan Guido. Dan is the co-founder and CEO of Trail of Bits. And in addition to his work at Trail of Bits and growing the company, Dan serves as a director at Hack/Secure, an investment syndicate focused on seed stage cybersecurity firms. Is active on the boards of 4 early-stage technology companies. He contributes to cybersecurity policy papers, and in prior roles, Dan taught a capstone course on software exploitation at NYU as a faculty member and the hacker in residence. He consulted at ISAC Partners, which is now NCC Group, and he worked as an incident responder for the Federal Reserve System. Hey, Dan, thanks for joining us.
Hey, thanks a lot. Yeah, I've been bouncing around finance for quite a long time.
Great. And last but certainly not least, my dearest coworker, Gilad Eisenberger. Gilad is the co-founder and CTO of Valid Network. He's an award-winning security geek, self-professed geek with over 10 years of experience in enterprise security. Gilad is a Microsoft veteran with extensive experience in developing and leading security development projects. He holds a Bachelor's of Science in Software Engineering from the Technion Israel Institute of Technology. Hi, Gilad. We haven't seen each other for hours already.
Hi, Oded. Hi, everyone.
Okay, guys, so we'll start with a quick intro and presentations of the companies represented here, and then move quickly to the Q&A, and we'll make the presentation stage short and sweet so we have a lot of time for discussion. Chris, would you like to go first?
Sure.
Great.
Okay. So I'm Chris Cordy. As mentioned, I'm a software engineer on Splunk's blockchain team, and I'll be talking briefly about some of the DLT security work that Splunk is doing. So first, I want to talk about sort of changes that have been happening in the DLT threat landscape. We see hundreds of millions of dollars in losses over a variety of threat categories. Some of these are not attacks on blockchain infrastructure themselves, but more just crypto facilitated, like ransomware. Some of these are exploits on smart contracts attacking either logic vulnerabilities or economic vulnerabilities. Some of these are targeting related infrastructure or key management. It's like private key theft. And some of these are more social in nature, like phishing. Of course, some attacks bridge several of these categories, like fraud. But if we compare this to previous year, some disturbing trends like ransomware revenue has tripled. DeFi, which had basically 0 reported losses in 2019, now has more than 100 million. Of course, a lot of that is because it has exploded in popularity, but we're seeing that there's this diverse range of threats that are all being exploited for tons of money, and we need to improve the rigor of both the proactive and reactive security measures that we have for blockchain projects. Part of what makes this a challenge is there's such a wide range of threats, and monitoring these requires a very diverse set of data sources. They can be on-chain like blocks or events, or off-chain like the node or host logs and metrics and peer-to-peer traffic. So this challenge is something that Splunk excels at because as a data to everything platform, it can take large amounts of structured and unstructured data, and it can take that from the blockchain and then build correlations. You can use your blockchain data to correlate with your regular infrastructure data to get key insights into the security and performance of your infrastructure, and just get a better view into the security properties of your network. An example of one of the tools that we have made at Splunk is Splunk Connect for Ethereum. This is an open source connector which facilitates getting some of that blockchain data both on and off chain into a Splunk instance for analysis. So again, as it's only one small piece of the puzzle of all the data sources that you would need, you would want to correlate that with maybe your CloudWatch logs, maybe your host logs, Kubernetes, Docker. But basically you now have enriched data that you can build correlations with. And some of the nice things it does include decoding of events, ABI decoding of events and functions. So it's a little bit more than just, so it lets you get a little bit more insight into your blockchain data. And yeah, it's open source, so anyone can take a look at that. So thanks, and splunkdlt.com is where you can learn more about some of the stuff we're working on.
Great, thanks, Chris. And there's awful lot there that we would relate to probably in the presentation. And Martin, would you like to go next?
Yeah, absolutely. So once again, thank you for having me on this webinar. I'm Martin Dirk. I'm from Quantstamp. So I will not be sharing slides. I will just give you a very brief intro. So Quantstamp is a blockchain consulting company with a strong focus on security. So we primarily provide security audits for projects that are building on blockchains, as well as the blockchains themselves. So that would be the layer 1 platforms and the layer 2 scaling solutions. I guess most notably last year, we audited 2 implementations of Ethereum 2.0. That was Teku by Consensus and Prism by Prismatic Labs. But we also audited Cardano, Avalanche, Equilibrium, Polygon, and Matic as the scaling solution for Ethereum, and many, many others. We have also completed some very successful POCs with industry partners such as Toyota and governments. That would be government of Dubai. And me personally, I'm a senior research engineer at Quantstamp, so I do conduct security audits. I have a first-hand experience, as well as I develop whenever we have development engagements. And my experiences before Quantstamp did provide me with both industry backgrounds. So I did work in small startups, as well as some large technical corporations, as well as Oded mentioned, I do have some background in academia. So yeah, that's everything about me, everything about Quantstamp. You know, happy to be at this discussion.
You're a humble individual, Martin.
Thank you.
Dan, tell us about Trailbits.
Sure thing. So, all like Quantstamp, we're a software security research and development firm, but we are not a blockchain firm. So we were founded to be leaders in the field of software security research and development. I started the company about 10 years ago with 2 other friends of mine, and we've grown it up to about 80 engineers now. And about 4 years ago, we realized that the skills that we had applied extremely well to this field. So we've now built one of the largest teams that offers blockchain security consulting services. We work with smart contracts, we work with blockchains, we work with custody systems, but we also do a lot of things that are not related to that at all. So we have expertise that we can bring in from fields like defense, tech, and finance that help our clients think through security holistically from end to end. We also have a team of really expert cryptographers that work on modern crypto as well as not so modern crypto. You know, they can help you figure out how to use OpenSSL correctly, but they can also diagnose performance improvements for your zero knowledge proofs. A lot of the work that Trailbits does is actually with DARPA and the US government. So we're on multiple, 4-year-long research programs to improve the state of software security for compilers, for programming languages, for program analysis techniques. And those are a lot of the techniques that we apply when we work with clients of ours. We can take the latest and greatest academic research and actually make it work on the products that you've built. Like the Quantstamp folks, there's just a litany of teams that we've worked with over the years. A lot of the people in the DeFi ecosystem right now are big on our client list. Firms like Compound, Aave, Balancer, those sorts of folks, Curve, whatever. We've also worked with a lot of blockchains themselves. So we've done Zcash, we've done some Bitcoin work. We also worked on a bunch of Ethereum. And then we work with a lot of traditional financial institutions. I used to work at the Federal Reserve. I used to work at Goldman Sachs. Our office is in New York, right off Wall Street. So when people are building these large asset custody systems, they typically come to us for help. So I'm really happy to answer any sort of questions today about how you can build more secure code, whether it's for a blockchain, a smart contract, off-chain system, or just a technology system in general. I can, answer those questions for you.
And you will, and so you will. Thank you, Dan, for this brief. Gilad, do you want to present Valid Network?
Yes, thank you, Dave. So hi, everyone. I'm Gilad, presenting Valid Network. Valid Network is a cybersecurity company for blockchain. We help our customers de-riskify blockchain. Our basis is that the blockchain is insecure. The assumption that the blockchain is secure is incorrect. And we see that happening through various attacks throughout the networks, happening constantly. I think in this forum, I don't need to convince anyone that the blockchain has security challenges to be met. Valid Network helps our customers manage that risk, mitigate that risk, and handle it through our technology platform. I'll show that in just a bit. A bit about me, that already introduced me, but I've done security most of my professional life, formerly in Microsoft, doing enterprise security and then cloud security, some BI as well. And then 2.5 years ago, we founded Valid Network. Fear of my partner and I founded Valid Network and started focusing on blockchain security and how we can bring technology in to solve the security challenges that exist with blockchain and DeFi as a whole. A bit about what we do. We provide a platform, a data platform that helps traders of all sizes, small to large, manage their risk in blockchain environment in DeFi with crypto assets. We help them assess risk for assets before they invest in them, as well as receive real-time notifications and updates about events that occur that might affect their stance, offering them access to opportunities that we can expose to them, or notifications of risks that they might need to be aware of to handle their investment and their trading as appropriate. Our platform provides a clear risk level, actionable alerts, and then forensics to investigate incidents that occur, deep dive into transactions, contracts, risks, anything that might interest the customer. And I'm happy to discuss the challenges that exist with DeFi security on the blockchain.
Great. So maybe we'll start, with the common blockchain attacks that you guys and your companies have witnessed over the past year. And then, given the many projects that you mentioned in your introduction, would you want to share with us what are the repeating threads that you see in the hacking and security glitches in the blockchain world?
Yeah, sure. So this answer is kind of underwhelming, and I feel really bad about it, but we actually published an academic paper on this. We have hard data to fall back on. And you're right, we have a lot of visibility because we look at more projects than really anybody else. So, well, I mean, I guess there's other folks like Quantstamp and whatnot, but more than any typical blockchain company would look at, right? So we went back and reviewed every single security review we have ever done, and we aggregated all of the bugs that we find and all the severities for them and a couple other details, and we published it in a paper at Financial Cryptography 2020. And the answers are underwhelming. It's like improper access controls, a lack of data validation. It's a lot of the real basic stuff. And I think this comes from two different directions. On one hand, the primary language that people are using to write primarily Solidity smart contracts includes a ton of footguns. It is difficult to write a secure Solidity smart contract because the language itself was not designed with security in mind, just flat out. It includes like a different order of operations than C++ does. It does a lot of like really boneheaded sort of things that make it more difficult for somebody to learn the contours of it. But something that compounds this is that today in 2021, we have excellent tools to check for many of those things. The security community has stepped up, and we have created all kinds of automatic checkers and analysis tools and analysis workbenches. The one from Strelobits that we put forth most prominently is called Slither, and people don't use them. We keep track of when people are exploited on the blockchain. Is this a bug that Slither could have found? And more often than not, if it couldn't have found it directly, it would have given hints in the right direction. So there definitely is like kind of a gap here where there's a lot of folks that are kind of bringing up the rear when it comes to software security. Now, obviously, there's more complex attacks. There's these like flash loan sort of things and economic issues that are being exploited. But I feel like the day-to-day is really the basic stuff. And I know that Martin wants to chime in. So go ahead, Martin.
Martin, do chime in.
Thank you. Yes, please. So mostly I agree. Sometimes I disagree. Here's the thing. I think that the question as it is asked is mildly wrong. So, if you have the most common attack and that attack costs you nothing, it's almost irrelevant, right? You can get hacked 5,000 times every single time for $5. You will wipe your tear, but it will not be devastating, right? So we should be asking, what are the most devastating blockchain attacks that are happening? So
Martin, what are the most devastating attacks that are happening on blockchain?
Yes. And so those are actually the economic manipulations. So that's what Dan mentioned. It's the flash loans, flash swaps, and sometimes you can include those. So when we speak about blockchain attack, it's kind of like there are many trends that you can observe, right? When you look back to like 2018, 2017, you would be talking back then about attacks and vulnerabilities such as reentrancy or integer overflows and underflows. And throughout the entire time, we would be talking about those missing input validations. So this is as old as the blockchain itself, and thanks to the tools that were developed, including Slither, these are actually these days not so much of a problem. I think that it's very rare for me as an auditor to actually these days come to a project and say, hey, there is a reentrancy vulnerability there and it's not benign and it actually can be exploited. But what becomes more and more and more prominent topic are those economic attacks, which kind of appeared with the rise of DeFi. So in DeFi, decentralized finance, what we see is that projects very frequently integrate among each other. There's that meme phrase, money Legos, right? So I will build my, yield aggregator on top of Compound that is built on top of Aave, and many, many, many layers of DeFi can be kind of built one on top of another. And so what happens with those economic manipulations is that I am attacking your project that invests into the structure that is trickling down. But before I attack your project itself, I actually perform some manipulation of the market in that underlying structure. So for example, what I can do, I can just go to Uniswap and I can buy all the DAI that is available on Uniswap, and somehow DAI suddenly appears extremely, extremely valuable and precious, and its price instead of $1 is suddenly. And when your project that I am attacking invests in manipulated market, it just like doesn't behave the way that the developers intended and presumed, right? And these vulnerabilities are extremely devastating. They are very hard to discover, and they are actually fairly hard to discover using the automated tools, because the big problem in there is that you have your project, and that's what you analyze through tools such as Slither or Mithril or all the other ones. But then you integrate with that structure that can have depth that is very, very large, right? And the question is, where do you stop? So do you analyze your project and Aave and Uniswap and Compound and everything at once, or do you not? Where do you stop? And if you decide that you will stop somewhere, then your vulnerability can be still present in the underlying layers. So yeah, those are my 2 cents.
Gilad calls it contract spaghetti. Gilad, you wanted to relate to this question again. So what are the most devastating attacks that you've seen over the past year?
So I think over the past year, we've seen, especially with the rise of DeFi, many cases where the security vulnerability in some way comes from a sort of fraud, or at least perhaps it wasn't premeditated, but where the attack eventually comes in from the owners of the project or those that are running it. Lots of rug pulls and other types of frauds that are designed to get money from their effectively from their customers and just run off with that, with those funds. And I think while the financial impact of those hasn't been that large, there haven't been large projects that have super successful that have performed these types of frauds. But it certainly impacts the trust that people have. And a lot of the investors, especially those that are less informed and don't really have the opportunity to do the proper review, feel a lot of pressure about the possibility of losing their funds to effectively fraud, and they don't really have the tools to protect themselves from it. So I think it's devastating in terms of the reputation of the industry and blockchain and DeFi as a whole.
Sure. And Chris, you had a beautiful slide about the trends that we're seeing in blockchain security. And I was wondering, what do you see as the biggest challenges that blockchain and DeFi ecosystems face nowadays?
So in some days, DeFi feels more like the earlier days of smart contracts, where innovation is outpacing just like security maturity. I think that's a significant challenge. Something to keep in mind is just the amount of, with more assets, of course, the target becomes a lot larger for compromise. So generally, I think challenges are keeping up with keeping security standards up to date with the fast moving technology innovation. I do want to say also that one last thing that wasn't touched upon was private key theft and key management is still a common enough issue that people should still be mindful of with like SIM card hacks or exchanges losing keys. Just wallet management.
And Martin, you said, why care about, a lot of little hacks that don't do a lot of damage? Everything is essentially solved except for those extreme cases which cost awful lot. So what are the challenges? If we have a vaccine for most of blockchain issues, what are the challenges that the industry is currently facing? And Christopher also mentioned the existence of standards for security. And I was wondering, what are these standards? How standardized are the measures in the security world for blockchain as opposed to traditional computer systems?
Right. So first of all, I have to correct you a little bit. The fact that I said that you can get hacked many times for $5 at a time, and it almost doesn't matter. That's actually not true, obviously, right? So everything matters, and the fact that your vulnerability can cost you $5 doesn't mean that another project will not be damaged much more severely. So obviously, everything matters when you're looking at the smart contracts and project. You have to look at them as a whole things. Even a small leakage, even a small input that was not validated, even a potentially let's say isolated access control modifier that is missing, it can have very, very severe consequences. I am not entirely sure if everything is solved. I would not call all these tools a vaccine. And I guess the main difference between the vaccine and all these automated tools and scanners is that the efficiency of vaccine is fairly large. The problem that the automated scanners and tools have is that they very often report false positives or true positives that actually do not have any potentially monetary impact on the project itself, right? So for entrancy, it's a very old vulnerability where you can have a call from a method to a different contract, which in turn again calls your method. So it's kind of like a nested recursion through some steps. The truth is that almost every other project contains the opportunity for this, right? But in 99.9% of cases these days, this vulnerability is actually benign. It cannot cause any financial damage, and the attacker cannot help themselves by the fact that they can introduce or they can execute some sort of re-entry into a method. But here's the deal. If you're really implementing a security scanner, then you should be somehow visualizing it to the user and reporting it as a potential problem. And then somebody has to come and they have to decide whether this really problem is or whether this is benign, right? So the tools themselves a lot, but they are not going to save the world, in my opinion. And so what could save the world here, and could with a question mark, in my opinion, is formal specification and formal verification, which is extremely hard to do. So and this kind of touches on the standards, right? So when you are implementing some kind of a smart contract, what you can do is yourself or some other consulting company can compile for you, let's say, set of properties that have to all the time hold throughout the life cycle of your project and throughout the, like, let's say, duration of your smart contract. And this is then encoded in some form of a formal language that other programs and other pieces of software can read. And then they can start searching through the space of all the possible states of the blockchain, whether exists of a sequence of transactions that can violate all the properties that should always hold, right? But this is actually, it sounds really nice. It sounds really neat. We use it all the time for things like planes and such, but it's actually really hard to implement these things in the blockchain space because it's very, I would say, time consuming. It requires a lot of expertise. And if you do it wrong, then you do it wrong, right? If you just, by the way,
following the standards or even defining the standards,
even defining defining the standards in this sense of standards being the strictest possible thing with the formal spec and formal verification. So if inside of your spec you say it's cool that my project loses some money, then the scanner that is then validating your implementation against the specification will obviously find and say specification says that this is cool, but I'm not reporting anything to the developers, right? So this is really hard, but I think that this is something that the DeFi space should actually really consider these days, because you know, my experience as an auditor is whenever I audit a DeFi project, I always have to take a look at what it is integrated with, and I audit, let's say, 17 projects within a month. And for at least 15 of them, I go back to platforms that they are integrating with, such as Compound, such as Aave, such as Uniswap. And I have to double check and verify the exact return values and exact behavior of those integrated platforms with respect to how the DeFi project is
touch on what audits are and what they should include in just a second, but I want to give Dan and Charles an opportunity here to relate to the standards. And like, Dan, who should write them? How would we come about, you know, with something standard to relate to when we're looking at a security problem?
Yeah, sure. So I definitely agree very much with Martin here. And I just wanted to kind of offer my perspective on formal verification a little tiny bit, because I feel like people hold it up as this big abstract unknown, where they're like, what the hell is formal verification? That sounds like something a bunch of academics do. Like, you need, you know, Martin with his PhD to sit next to me and he's going to do it because my team clearly can't. But that's totally not true. You know, we really see it across all of our customer sets where most people are at the stage where they can compile the software, and if it compiles, they can ship it, and that's fine. And then the really, really good ones do unit testing. And unit testing is like a super advanced science to most people. They're really proud when they get like 100% coverage for unit tests. But very few people come to us with any knowledge of what formal verification is. So at its core, it's just like, you know, as we've been discussing, it's knowledge of what your program is supposed to do. Now, there's different ways you can specify that, where it's very fine-grained or very high level. And I think what we've gotten really good at in both the blockchain industry and with the consulting that Trail of Bits has done is found ways to make them very high level and very amenable and very understandable to people that already write unit tests. So we have a different tool. It's a little bit harder to use, like I understand, but It's called Echidna, and it allows you to specify these security properties in Solidity alongside your code. And they can be very simple. So an example of a security property for someone that's never heard one before is if you have an ERC20 token, which most people would be familiar with. A security property would be if I transfer money from my account to your account, then my account goes down and your account goes up. That's a security property. And then what you can do is you can use something called an automated test generator that essentially creates millions of little tests that try to check all the different behaviors around that property. So what values could I possibly send where I'm supposed to be transferring money from me to you, but somehow I end up with more money and you end up with less, right? And maybe you'll find an integer overflow or some kind of wrapping issue, right? So these kinds of security properties, they're not as hard to get started as a lot of people describe. And you can always start easy, like having a program with one security property is better than a program with none. And once you get the ball rolling on the properties, then you can start to think, how do I prove them? And that's a whole nother question, because like I mentioned, you can prove them with what you call an automated test generator, or you can prove them with a formal method. And the level of effort to change between the two is sometimes high. It might be hard to use a formal method, but easy to use an automated test generator. But the automated test generator might get you like 95% of the way through. So it's all about controlling for your risk, having properties and even testing them with like quote unquote crappy testing methodologies is still going to be way better than not. So I didn't answer your question really, but yeah, Charles, you've been waiting.
It's okay, but we're setting a framework here. Martin says, let's ask a lot of questions. Dan adds, when you ask a question, make sure that you test it, and any test is better than no test. We're getting to something here, but I wanted to give Charles an opportunity to echo his opinion.
Yeah, and to be clear, it's like
Charles, you have to introduce yourself first, because I haven't had the privilege to do that on your behalf.
I'm the technical program director at the EEA. I have a background in technical standards development, web standards development, a degree in medieval history, so I'm not quite at the academic level of, say, Martin or anyone here really.
Not a competition.
In security. Where I wanted to go was to actually look at the standards, because this is what EEA is doing. This is what we are doing. To answer your question, who should be writing the standards? So by and large, security people should be writing the standards. The people who have, the experts on this panel who have the detailed knowledge of, okay, here's a problem I can describe, and here is a way that you can test for it that makes sense. But I think there's a piece that you want to see when you go out into the real world. Dan mentioned there are an awful lot of automated testers and automated tests that can be run, and there's an awful lot of people who don't run any of them. And so, the first thing is to say, look, it would be great if people ran tests. What tests? How do you know whether you should contract, Quantstamp or trailer bits or diligence, or there are any number of people who do this stuff as a service. How do you know whether you should be using the EY tool or the PwC tool or Slither? And so what we're trying to do at EEA is actually say, let's have a look first. Our sort of starting point was smart contracts. Let's have a look at smart contract code, because that's a thing that people talk about a lot. And let's actually figure out across the industry, what are the things that you absolutely should check for? And this is not about, we are going to provide you perfect security, right? If this, particularly, as Martin pointed out, if you're only running automated testing, if you're only running the first level of testing, so yes, you absolutely should be doing that, because one layer of security is better than none. But it is only about managing risk. It's about making sure that you've got a minimum base that you're looking at. And the key piece is to actually get all of these experts, the experts on this panel, the other experts involved in the work, saying, okay, here are a set of things that you really got to test for. If you haven't done that, you haven't even got to first base.
Charles, we're not setting a work group just during this webinar, but hold that thought. Hold
agree.
that thought. I want to move forward with your permission to, you know, there seems to be two questions here that both need to be addressed. One is like, how do I approach the security of my blockchain project when I set to launch, when I just developed the smart contract for the very first time? And then again, how do I protect my project once it's already in deployment and attacks keep coming despite all of our good attempts and audits at the beginning stage? So maybe we'll start with how to approach, you know, the project, or what's the checklist that you would look at when you're launching a new blockchain project. Dan, do you want to go first? Like, what is your
sure.
like, quick?
I can say things,
quick
but it's going to
check
be
of,
funny
like,
because a lot of
5
it's going to
things
echo
that you do.
what we just talked about. So, like, one. Yeah, my internet connection is unstable. Here,
Okay. Until
Hello,
Dan
okay.
repositions.
I'm good.
Martin, do you want to take this one also? What are the 5 things that you would focus on when setting a new project?
Right. So I guess the first thing that I want to say is that security cannot come to your project as an afterthought. If you start developing and finish beginning to the very end, and then you are like, how about security? It's not too late because you haven't deployed it yet, but you will have lots of troubles. It actually has to become the integral part of your development process. That's not so common in regular software engineering. When I'm, developing an application that I'm going to be using in person right here on my desktop, I give very little thought to security, right? Or any other developer does. But here we have to understand an application will be residing on blockchain for and ever and ever and ever. So already at the very beginning, we have to think about security. And with that comes, good engineering practices. So the fact is that smart contracts and blockchain projects, they are actually the code bases for them. They are significantly smaller than regular, server code. If I want to capture the size of a regular project on blockchain on Ethereum, it will be something between 1,000 and 3,000 lines of code. That's actually not that much compared to other projects, right? So it's very tempting to start like just messing around and be like, yeah, I will figure it out as I go. But this is already the wrong approach. So start thinking about security right away at the very beginning. Testing was brought up several times here. So right at the beginning, start using some kind of framework that is the projects on your particular blockchain. Talk about Ethereum, that would be either hard hat or truffle, and organize your code with the philosophy of this particular blockchain, of this particular framework. So in both of these, you will have your folder for smart contracts, you will have your folder for tests. That folder with tests cannot stay empty, period. So definitely do test. Another thing that you also have to do right at the beginning is kind of put down some specification, put down on some document what you actually want to develop. And when I say that, like, just forget about all these white paper sections that you see in all the projects where you promise your token economy to somebody and, like, omit the investor section, focus on the technicals. This is what I'm building, and this is how it's going to work.
Great. Dan, you're back with us. Can you add your sense about launching a new project, and what are the things that you would look at from a security perspective?
Yeah, so 2 really short things to add to that. So one of the ways that we see most of these initial launches go really bad is that people fat finger or forget to include some information that's critical for their deployment when they're actually deploying the code. Deployment should be automated. And that goes to like using a framework like Hardhat, but it goes beyond that as well. If there are any steps that are manual in your deployment process, they should not be. You should get rid of them. Every single thing should be done by a script. If it can't be done by a script, then you're doing something wrong.
Never trust humans.
No, ever. We've seen a lot of blockchain projects screw up that way. Second thing is, like, you know, monitoring a smart contract is a lot different than monitoring like a typical web application or some other microservice or whatever that you put out in the cloud. Like for those, the failure cases are quite well known. Like if the software crashes, you've got a problem. If a web shell pops up on your file system, then you've got a problem. Like there are well-known failure cases that you can search for your Splunk logs to find. However, with the smart contract, you don't know what the conditions for failure are unless you do the work to define them. So this all goes back to that security properties again. What does good operation look like? And what does bad operation look like? And once you have that definition written down somewhere, then you can start to think through, well, what am I monitoring to find? Because there aren't these like well-known cases. Your smart contract isn't gonna crash. Like that's not a thing that happens with a smart contract. So you can't just search for it. You need to actually figure out what are the parameters inside of which I am going to monitor for. And that's something that an audit and that a security consulting firm can help you figure out. And it's a really critical beginning for an incident response plan is, when do I know things have gone off the rails?
Thanks, Dan. And with that, that's a good segue maybe to you, Gilad. So Valid Network obviously monitors a lot of networks and smart contracts in real time for issues that the developers never had, never given a thought about. Can you tell us about how should one monitor the project that is either running or project that is investing or involved in as one of the stakeholders in the blockchain?
Sure. I think one of the key aspects that applies both to when you're developing and applies manifold afterwards is around education. So it's important to be aware of the risks and the attacks and stay up to date with things that are occurring. We've seen attacks happen where the same methodology was then reused on contracts that had the same vulnerability as was used previously. Sometimes there was a day between them, sometimes even more. And that would allow these developers, owners of the project, or even the investors to be aware of this vulnerability, to understand that it might apply to their code as well, and take action that's necessary to protect themselves from that risk that still exists. When they have this opportunity, the attack is known. It's sometimes difficult to protect yourself from the unknown, but at the very least, you should educate yourself to make sure that you're protecting yourself from the things that are known. And I think another big challenge around protecting yourself in the public blockchain arena is that there are no attack attempts on the blockchain. There are only successful attacks. Since the ledger is completely open, an attacker can simulate the attack ahead of time, collect intel, and perfect the attack before it's executed for the first time against your contract. That means that you won't really have an opportunity to see the attack before it starts. Sometimes the attacks take a while to unfold. They might take a few transactions or even more to completely exploit them. So there is a small window, but there's no warning of an attack. There's no traditional firewall monitoring where you can see there are attack attempts and start to protect yourself against an upcoming threat. So it's important to consistently monitor your risk, understand which vulnerabilities exist, what the risk is in terms of the assets themselves, and of course also in terms of the value of the assets. So just protecting the assets themselves isn't sufficient. You need to make sure you protect the value that's behind those assets. So as an example, the fact that I have a certain amount of tokens isn't necessarily worthwhile if I, for example, can't do anything with them. If I have assets that are locked or the contract itself suffered a DDoS attack that prevents me from using them, while I still have these tokens, I still have the assets themselves. They don't have the same value that they had before. So it's important to not only protect the direct assets themselves and protect against attacks that directly steal the tokens, but also against threats that might impact the value of that asset.
Great, thanks, Gilad. And Chris, in your introduction slides, you mentioned that Splunk is one of the largest information companies and has a platform to look at different types of data and insights to generate some risk insights. Can you share some more details about that? What should developers and what should participants in the blockchain look at when they're monitoring their active projects?
Yeah, so there's certainly a lot to monitor. I already mentioned key management before, but generally, however you're going to be accessing your smart contract or your project, you want to make sure that you have good monitoring on that. Any sort of access controls, you want to be monitoring for, kind of similar to what's been said, where you want to have ahead of time an idea of what the expected range for certain state in your smart contract is. So are there changes in ownership, for example, or any config changes happening that might be indicative of something strange? As well as, you want to be monitoring the performance of your contract. Transactions per second are always, anything that's giving you insight into performance is also really good to tell you if something security-wise is happening, if balances are starting to act strange. Obviously, for seemingly instantaneous attacks, that's not incredibly helpful, but for several, it might be. And then also, a lot of the security, especially for these public chains, comes from the whole premise of decentralized blockchain, being that, you're not relying on a single trusted party. It's, if you are ever having at any point your own node on the Ethereum network, it's going to be really helpful for you to verify, if you're sending transactions to it, that it actually has a diverse view of the network, that you're not being targeted at a network layer or peer layer with like a BGP attack, for example, which is certainly going to be a very rare thing. But, depending on the stakes, is something that it might make sense to run multiple nodes, or just try to make sure that you're not only asking one person for the answer to something. So yeah, networking, performance, and then just all your host level monitoring as well.
One sentence to add to that, because something that you mentioned there was that you can emit events. So as a development exercise, when you're writing these contracts, making sure that you have consistency in the way that you're emitting events, and that you're emitting events for all the things that you need to. But obviously, like everyone I think has said so far, caveats apply to all this sort of monitoring stuff, because there's only so many kinds of attacks that it could detect. A lot of them end up being reliability issues, or like other kinds of performance issues, and the security issues, you're kind of just a sitting duck. So sorry.
Well, the world is not just perfect yet. So a lot of our audiences here are not, developing their own smart contracts, but rather looking at these white papers out there and thinking, should I get into this project or not? Should I take part or shy away? Gilad, I wanted to ask you, how can people trust a DeFi project or a crypto asset and say, is this project legit? Is this transaction maybe legit? Would this smart contract come back to haunt me? What can you do as an individual participant in the chain?
I think it again goes to education. I think there are plenty of tools out there that help you learn about the various assets that you're looking to invest. I think similar to how traditional financial investment has its own set of metrics and standards for how you'd investigate a financial asset that you're looking to invest in, whether it's Bloomberg, rating agencies, any type of rating that you use to make a decision in terms of traditional financial assets, the same kind of logic and methodology applies to a blockchain asset, with the additional complexity of it being basically a brand new world where you're investing in code, investing in the reliability of that code, in the reliability of the platform, and other risks that are exposed through this new mechanism that you're investing through. While it offers a lot of advantages, of course, in terms of liquidity, ease of investment, availability to everyone, no middleman, lots of upsides to it. There are naturally additional risks. There are also tools to monitor the risk of these assets, to evaluate them. Valve Network has one that allow you to evaluate the cybersecurity or other type of risks that's associated with an asset that you're looking to invest in.
Great. So with education in mind, Martin, I want to ask you, as the most educated guy among us, like, explain to the masses, what are like the 3 things that they can do in order to avoid, risking their good money and hard-earned cryptos?
Right. So when you invest into a DeFi project, it's very similar to giving your credit card plus the PIN code to a person. So you have to absolutely trust that person. I here actually disagree with Gilad a little bit, because he mentioned that we should way into its lifetime, say like 8 months, 9 months, a year. So it would have appeared absolutely safe, but it's actually not true. So do exactly the same thing as if you were handing your credit card to somebody. Know who that person is, what they need to do with that credit card, and then decide for yourself, would you do it or would you not do it? There are means out there to do that research. Usually projects have something like Discord or a Telegram group. So join those Discords, join the group, talk to other people. If you are technical enough to understand a little bit of solidity in the code itself, go to Etherscan, check what it is roughly doing, learn a little bit about the ecosystem, where the money that you are investing in is actually going and what's going to happen to it.
Great, thanks, Martin. Dan, last tip to the masses.
Yeah, sure. So, ignoring the question of how to review a security report, because I think that like security firms have become these de facto kind of bastions of truth where we can actually provide direct lines of information to engineering information without all the marketing BS that I think kind of pollutes a lot of the white papers out there. It can be very hard to figure out what somebody's done, but when you read a security review, it tends to be very clear. But ignoring that, I think there's a couple factors that I look for. Assets with really low liquidity are extremely risky, both from an economic attack flash loan standpoint, but also just because you're kind of like standing out in the field alone. So that's one thing that I would look for. The degree of centralization. How much do they depend on a single source of truth, like let's say Oracle out there? And who are those oracles? Like, what is the quality of that data source? Is another really great kind of question to ask. And then to echo a point that Martin made, like, who's the team? Like, do they have any relevant experience building the thing that they're trying to build? Because there are a lot of teams out there that are kind of just faking it till they make it, and the results aren't always pretty. This isn't a field that's very forgiving of even minor failure. So understanding who is behind the team and what their qualifications are would be another great one. And those are all like fairly, none of them have to do with the source code, or well, sort of. But I feel like those are fairly high quality leading indicators of success.
Great, thanks, Dan. And we're short on time, but Chris, your last tip for the masses, how to secure themselves in a risky world?
My most important tip would be, so much of security and performance monitoring and assessment really just depends on understanding what you're trying to do and what you're expecting to see when your project is working correctly and when it's working incorrectly. So this has been mentioned already, but yeah, sort of have correct logging, have a plan before you start, and then have a falsifiable way to, actually assess, is this working correctly when you're monitoring?
Charles, thank you, Chris. Charles, your last tip for the masses?
Get your security checked. Like, look around and see what people are saying and make sure that you're actually doing something, because there's a lot of people out there who would like to have a bite of your pie.
Absolutely. Thank you. So to end up, I want to thank EEA for hosting this webinar. Thanks, Brittany, Carol, Ken, Charles, and James. I want to thank everybody that has helped make this event happen. Thank you, dear panelists, Melanie from Splunk, Richard and Jay from Quantstamp, Peter from Valid, and Amelia from Trail of Bits. And we want to keep the conversation going. If you've got any opinion on the state of security on blockchain and crypto, if you're an EEA member and you want to get involved in defining challenges and finding the solutions for those challenges, please give us a shout. EEA is posted here in the chat, the EEA website and email addresses where you can get in touch. And also you can find all of our panelists on LinkedIn, Twitter, and we wish you a great day and tightened security for your blockchain projects and crypto assets. And, may we all be safe and prosper. Thanks, guys. Have a nice rest of the day.
Thank you, everyone.
Thank you.